Okay, so let's get back to class. So we have 3 more examples left for this handout. So we're gonna finish these 3 examples together, and then the plan for Wednesday, we're gonna start doing the review, and we're gonna do homework together on Wednesday as well. So but let's start by taking a look at 3 more examples. So make sure that you more comfortable with the polar coordinates. So example 61, I want you to integrate this one, but you can see that it is super hard to integrate dx dy here because you have square root 1 minus y square here and square root 1 minus y square here. So if you actually integrate it, it's gonna be impossible because this way you don't know how to integrate x squared plus y squared power 3 over 2. So it's gonna be easier to switch to the polar coordinate. So the idea is we're gonna switch to the polar coordinate r d theta. So it's gonna be a lot easier that way. So first of all, make sure that you draw the picture first. So it's actually x in between square root 1 minus y square and negative square root 1 minus y square. So this is actually x. Y gonna be between negative 1 and 1. So what is the picture here? So you can try to draw the picture here. Y and x. So if you simplify the top part here, so you can see this is actually one equation that you need, right? So you square it, so you're gonna have x squared equal to 1 minus y squared, right? And then you have x squared plus y squared equal to 1. This is actually circle. So you draw the circle, radius 1. This is actually the x squared plus y squared equal to 1. Right, and then it seems like all the region that you want is the if something here in the circle, right? Because why? Because like every time when you slice the x dy, it means you slice horizontally from here, here, you slice, right? You're gonna start from x equal to this part to x equal to this part. So this part on the left, this is actually x equal to square root minus square root 1 minus y square. On the right hand side, this is actually x equal to square root 1 minus y square, right? So this is the circle can be separated into 2 pieces. So the left one here and the right one here. The left one is this equation, the right one is this equation, and then you see that you slide the x dy this way, so it's gonna be from here to here, and then y gonna start from negative 1 to 1. It's perfect. So this is the picture that we want, and then now you switch the order of integration to polar coordinates. So it's gonna be r d theta, right? So r gonna start from where to where now? R gonna start from the pole here, and every time you do the cut here, r gonna start from 0 to 1, and then theta gonna start from 0 to 2 pi. Everyone agree? 0 to 1, 0 to 2 pi, because from the pole here, when you do the slide array here, so it's gonna be 0 to 1, and then the theta gonna run from 0 to 2 pi, and then the inner part here, so you have x squared plus y squared, you switch it to r squared to the 3 over 2, right? And then now it's time to integrate. 0 to 2 pi, 0 to 1. Inner part here, so you're gonna have r to the 4, right? Because you have this is r cubed, and then this is 1r, so this is r to the 4, and then now you integrate it, so you have r to the fifth power over 5, and then r start from 0 to 1, and then the inner part here, this is actually 1/5, so the answer is 2 pi over 5. You can see that it's pretty quick and simple if you use the polar coordinates here compared to using the dy dx or dx dy. It's going to be horrible because you need to integrate this one and then plug in this. It's going to take you to the trigonometric substitution. But here, if you switch to polar coordinate, because the picture is circle, you see? So when the picture is circle, easy because you're going to just have the easy upper bound and lower bound here. So remember, I equal to 0 is the pole. This is actually I equal to 1. So it's going to be here. R start from 0 to 1 all the time, you see that? And then theta gonna be from 0 to 2 pi because this means that every ray that we draw, we start from 0 to 2 pi. But like the previous question, we have 0 to 3 pi over 2 because we only do up to 3 pi over 2, this part. Make sense? Okay. This is a good example to show you that polar coordinate is important when you work with circles. So easier that way. So this is one example here. We have two more. So we're gonna next we're gonna switch the order of integration from dx dy or dy dx to polar coordinates. So let's do two more. So example 62, convert this one to polar coordinates. ไม่ทันนะครับ Okay. So for those of you who ready, you can draw the picture on example 62 and trying to see if you can draw the picture correctly. You start from rectangular coordinates in example 62, and then we're gonna do the polar coordinates together. But the first thing that you learn from example 62 is that you need to draw the picture first. Okay, let's go. So we're gonna do example 62 here. So everyone, you need to draw the picture where y between 0 to square root 9 minus x squared and x is between 3 and 3 over 2 and 3. So what is the picture here? So first of all, draw it y, x. So of course, y equal to square root 9 minus x squared. This is y squared equal to 9 minus x squared. This is x squared plus y squared equal to 9. So it's actually circle, right? Radius equal to 3. This is actually circle radius equal to 3. Make sense? And then basically you're gonna need the circle with radius equal to 3. This is actually circle radius equal to 3. X squared plus y squared equal to 3. And then now you also have y equal to 0. Y equal to 0 is what line? The x-axis. This is going to be your one cut. And then you have x equal to 3 over 2 and x equal to 3 as well. So that means x equal to 3. Sorry, this is 9. X equal to 3 and x equal to 3 pi over 2. Let's start from 3 pi over 2. So you're gonna have not 3 pi, 3 over 2. So this is 1.5. So what is the area here? Then it should be this piece, right? Everyone agree? Should be this piece. Why is that? Because if you do y dy dx first, so you're gonna be, you slide this way, see that, and then it means you, the bottom part here is 0, the upper part here is this piece, which is square root 9 minus x squared. So actually the one that I highlight in light blue, this is the one that we want, and then x start from 3/2 to here. Good. Everyone agree with this picture?
Yes.
Question. And now you switch it to r d theta. Integrate. You switch to fr cos, fr sine, and then r d theta. So what is going to be the lower bound of r here, and upper bound of r, and then this one as well. So it's gonna be your challenge here that you need to find all the question marks here. So what is going to be the domain of the upper bound and lower bound of the integration here. So imagine that you start from the pole and then you do the slice here, which means like every time when you do the slice, like the ray here, you're gonna start from this curve and then you hit this curve, right? So basically you need to start from this one up to this one. So the top part, x squared plus y squared equal to 9. This is similar to r squared equal to 9, right? This is r equal to 3. Make sense? So which means the question mark here that I delete, this is 3. You clear about this number 3 here? Because every time you do the slice here, you can see that the outer part is always this one. But the inner part, it's going to be this one, right? Because every time you draw the slice here, it's gonna be like that. So the inner one gonna be there, the outer one gonna be there. So the inner one is this one, but this one you need to switch to polar coordinate as well. So x equal to r cosine theta equal to 3/2, which means r equal to 3/2 cos theta. This is okay. So you're gonna do this from 3/2 cos theta. This is fine. Or you can, if you want to, if you don't like this one, you can do 3/2 sec theta. Same thing. If you don't like over cosine, so you can do 3/2 sec theta. It's okay. So this part that I highlight in yellow, this is the one that you use this lines as it. And then now your theta here gonna be where to where. So you have, this one is a little bit challenge in terms of you need the ray here, right? Because you actually need to know what theta is this, because theta gonna, of course theta gonna start from 0, but it's gonna go to where? Because you start from 0 here and then you keep going, and until this point you stop, right? You stop drawing array. So what is going to be the cut here? What theta it is? So this is actually 3/2, right? From the picture. What about this part? So you have to plug in 3/2 here. And then you solve for y, so you're gonna know the cut here. Okay, so we're gonna just say, I mean, if I draw the picture here from I just zoom in that part. So this is a theta I need, but I know that this is 3/2, and if I know this one, so you can have the trigonometric identity, and then you can find theta. So this is x squared plus y squared equal to 9. So 3/2 square plus y square equal to 9, and this is 9/4 plus 9 square equal to 9. And then that means y square equal to 9 minus 9/4. I'm just 36 minus 9 is 27, right? 27/4. So which mean this is actually 3 square root 3 over 2, right? Because 27 is 3 square root 3. Oh, sorry, that's y square. So just y, this is 3 square root 3 over 2. Because if you square it, so you're gonna get 27 over 4. Which means you have that tan theta equal to 3 over 3 over 3. Tan theta equal to square root 3. Right? And then at the end, you're gonna have that theta equal to 60 degree or pi over 3. Does it make sense? Because it look like you're trying to find what angle it is here, so you can find what where the theta stops. So you want to find the angle here. So the angle I found it at the end, it's gonna be pi over 3. I know it because this is 3 over 2, and then this is 3 over 2 is here, and then I know that the equation is x squared plus y squared. Oh, did it too fast. So it should be 3 square root 3 over 2 over 3 over 2. So it's cancelled out already. Yeah, I did it too fast. But actually you just do y over x and then you cancel, and then you're gonna get that angle. Okay. So you get this one. So this question is is the challenge one, so that you need to find the angle you want in order to know where you stop. But the inner part and outer part is okay because you just switch the rectangular to polar coordinates. This is similar to the last question on the final exam, so it's gonna be the complicated one. So you're gonna have one question at the exam that challenge you on the last one, something like this. So it's gonna be challenge one that you need to switch the domain of the integration. Okay. Okay, anyone want to jot down and want to take a picture, you can do it now. So we're gonna move to the last one. So the homework 5, homework 4 due today, but homework 5 we're gonna do it together on Wednesday in class. So you don't have to do it by yourself, but if you want to do it by yourself, you can do it beforehand, but I'll explain in a little bit. Once we finish example 63, we're gonna explain a little bit about how to collect the point for homework 5. Okay, the last one is example 63. Okay, ready? So example 63. Okay, draw the picture first. Again, we want to switch the x dy now to polar coordinates. So draw the picture. So now it's gonna be x between y squared and 1. And then y gonna be between 0 and 1. So you draw the picture first. So x gonna be from y squared to 1. So x equal to y squared. This is actually the parabola here. X equal to y squared, right? And then x equal to 1. X equal to 1. Okay. And then now, what is the region now? What do you think? So when you do the x dy here, you actually need to cut this way, right? It's gonna start from parabola to x equal to 1, but y start from 0 to 1. So the intersection here gonna be 1, 1. So basically the thing that you want is the one that I highlight in orange. Agree? This is the one that, well, I mean, you can see that the x dy is cut this way, and then parabola is on the left, x equal to 1 is on the right. That means you have the cut here, and y from 0 to 1. So this skill we already learned last week, and then now you switch to polar coordinates. Okay, how to switch to polar coordinate then? So every time when you cut here, you can see that. So you need to split the region, right? Because if you zoom in the picture, you're gonna see that it's gonna be the case that you have to split into two pieces based on the dashed line. So the first one you go this, hit the line x equal to 1, right? Hit the line x equal to 1, hit the line x equal to 1, and then you stop because after this dashed line, you hit the parabola, right? So you split into two pieces. Not easy, nah, this one. And then you can see that the first one you're gonna start from I equal to 0 to x equal to 1. This is r cosine equal to 1. So I equal to 1 over cosine, or it's actually I equal to sec theta. So the 0 to sec theta, this is the first piece. The second piece is 0 to parabola, right? 0 to parabola. Parabola y equal to x equal to y square. The parabola is r cos equal to r square sine square here, which means you're gonna have cosine theta equal to r times sine theta. This is actually r equal to sine square, sorry. I cut one r out, so I have r equal to cosine over sine square. You don't have to simplify, but if you want to, it's actually cosine theta over cos is cos over sine is cot, right? Cot and cosec. Okay, before we find the angle here, you can see that the picture gonna be two pieces. The first one here, similar to that. The second one is starting from this line. It's gonna be the picture gonna be super small, but this piece gonna correspond to this one. And then now what is the angle here that you cut? Because it passed 1 1, so actually you know this is actually 45 degrees. So this is easy, pi over 4. So 0 to pi over 4. Right? Because you actually know that it's part 1 1 here. This 1 1 here, this should be pi over 4. This is actually super easy one. You can do tangent theta equal to 1 over 1. So it's actually pi over 4. Because it passed the point 1 1. You already know it. So it is pi over 4 here. And then at the end point, what is that one? So it should be pi over 2. It is actually pi over 2 because you're gonna go that, and when it's pi over 2, it's n. It's n here, right? You don't know that it is pi over 2? Because like every time 45 and then you keep going, and then at 90 you end. Is that correct? Like, yeah.
It's right.
Mm-hmm.
It's hard.
Well, I thought that it's like from in intuition that you know that it's pi over 2. But pretty simple that.
We know that pi over 2 คือ90 องศาจ้ะ we know.
This is actually the line. This is the axis for pi over 2, right? So, well, if you feel like you are not comfortable, you can plug in pi over 2 to this line, and then you can see that it's gonna stop cosine pi over 2 and cosec pi over 2 gonna stop at 0 immediately. Right? It's gonna just like you just plug in and then it's gonna done here. Okay, this picture is way too small, but usually if you draw it more this way, so you're gonna see more that it's actually go here, 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 but the radius gonna be a little bit smaller each time, and at the end it's gonna be done at 0. It's done at 0. Make sense?
อ๋อแล้วต้องคิดตรงที่ r เป็นศูนย์
ไอ้ดิก็มันเบาถึง
ต้อง
90
r ศูนย์
Well, because when theta start from pi over 4, it's actually here, right? But when theta keep going, it's just a little bit, the value here gonna be, you get smaller each time, but when it hit pi over 2, this is actually done at 0.
คือกูเข้าใจนะแต่ว่ากูทำไม่ได้
Well, if you can do it, you deserve for an A. If you cannot do it, so I don't know.
เอาปะ
Okay, now this is the last one, example 63. So do not guarantee that the exam going to be this hard, but well, I will put challenge question for sure, just to make sure that everyone have. So we're gonna stop